So we are moving on to Unit 7.8, which we talked a little bit about in class today. We are going to factor the special products that we learned about a while back, and we've got the difference of two squares to start off with. We talked about this a little bit in class. What is important to remember when you're looking at the difference of two squares is that you have to recognize that you have a polynomial with a square in both the A and B positions, and there is a negative, okay? So it's actually a binomial with two squares. So it's not a shortcut, it's not a trick. What it is something that you have got to recognize. You have to remember this. You have to know what it is, because if you don't catch it and you think, oh, there's just two terms in that polynomial, it's obviously not factorable, and you don't catch those squares, then it's going to be wrong. So just remember the shortcut from when you multiplied, where you square that first term, you square that second term, and those inside terms cancel each other out. So moving on to a few examples. Let's look at number 1 here. We have s squared minus 49. Well, when I look at that, I see that I can take the square root of s, and I can take the square root of 49, I'm sorry, s squared, and that gives me s and 7, but it's a difference of squares, so we have to put s plus 7, I'm sorry, s minus 7, and s plus 7. Moving over here to number 3, looks a little bit different. You can do it this way, but just to be consistent, we're going to go ahead and put it into standard form. So that gives us negative x squared plus 16. The first thing we need to do is check for a GCF, and we've got one in the form of a negative 1. And now we see we've got a pattern that we can recognize as the difference of squares. So we can take the square root of x squared and the square root of 16. That will give us x and 4. So we know that has to be, we can't forget our negative, we know that has to be x plus 4, x minus 4. As Ms. Maria said in class, it is going to be really, really, really helpful if you will go ahead and make yourself that cheat sheet of all of your perfect squares through 20. So if you want to pause it right now, make your cheat sheet. You can refer back to that easily, recognize those squares when you see them. It's going to go much faster, make your life a lot easier. So go ahead and pause it and make that cheat sheet right now. Okay, so we're going to move on to number 5. We can see here that we have 36h squared minus 121. If we take the square root of 36h squared and the square root of 121, we get 6h, and we get 11. We know this is a difference of squares, so we finish that out with both a positive and a negative. We are going to move on. Y'all y'all want to work on these other ones, get a little more practice, you can do that. Let's move on. Move on down the page. Now, these look a little different because we don't have any x's, we don't have any variables. But guess what? These are actually really, really easy to solve. Who can tell me what the square root, I'm sorry, what 57 squared is? Probably no one without a calculator. But you know what we can do is see there is a pattern. We have square numbers and a negative. So we know that this is a difference of squares. And we can factor it out like that. Way easier problems here. We've got 57 plus 53, which is 110. We have 57 minus 53, which is 4, which gives us our answer of 440. Super easy to do it that way, not as easy to find the square of 57. So I'm going to go ahead and I'm going to skip 8 and 9. Those are pretty self-explanatory. If you want some extra practice, go ahead and work on those. Let's move on down to number 10. So we're going to solve the equation. So we're solving for 0. I see I've got a perfect square here, a perfect square here, and a negative in the middle. We know we can take the square root of x squared and the square root of 144. We can get x, and we will get 12. We know from the pattern that it's a difference of squares. So we finish that out. We have our factored equation. Solve for 0 on both sides. I mentioned this earlier today, that those are basically the same problems, just with different signs. So we know that we really only have to solve for one. We need to take that 12 and put it over here, which gives us x equals negative 12, but we know because of the other problem over here that we'll have a plus or minus 12. You can always go back and plug that back into the equation and make sure that gets you 0. Number 11, that one looks really different. So there's a few ways to solve this. We are going to do what we normally do and make that equal to 0. So we've got 9y squared minus 49 equals 0. I see a pattern. You all should see the pattern as well. Square root of 9y squared. Square root of 49 will give us 3y and 7. We've got a negative, makes it a difference of squares. It does not matter if you put the negative or the positive first, as long as you've got them both in there. And now we're going to solve for 0. Move that 7 over to the other side. 3y equals negative 7. Divide that by the 3. Y equals, got a negative over here, but we know because there's 2 of essentially the same equation with different, with negative and a positive, that's going to be a positive or a negative 7/3. Awesome. Moving on to our second core concept, again, we talked about this today, that is the perfect square trinomial pattern. So this is a shortcut for factoring. This is going going to skip a few steps. If you recognize this pattern, then you don't have to do all of the steps. You don't have to do the magic number. You don't have to factor by grouping, because this pattern tells you that this is a perfect square. This is one binomial multiplied by itself. And the way we see that is we've got a square on each end, and then our middle term is twice the product of those two ends. And it's really important to see and recognize if you have a positive or a negative, because as you can see, that is going to affect whether your binomial is a positive or negative b in that binomial. So as you can see over here, let's look at this first example. We've got a x squared and a 9. Okay, that'll work. But you can't just say, oh, this is automatically a perfect square trinomial. You have to figure out if the a and b, the product of a and b times 2 equals that middle term. So the square root of x squared is x. The square root of 9 is 3. 3 times x is 3x, times 2 is 6x. Yes, that works out. And there you go. We see that that is a perfect square trinomial. Let me just show you really quickly why you can't just leave it as, or I'm sorry, why you can't just assume that anything with a perfect square on either end is going to be a perfect square trinomial. Well, I can factor this. This is our magic number, sorry. We've got 4. So what two, 5 down here, what two numbers multiplied together, when added together equal 5? Well, we know that's going to be a 1 and 4. So we've got x plus 1 and x plus 4. Well, that's not a perfect square. That's not going to work because that middle term does not work out for a perfect square. Even though we have a square here and we have a square here, this middle term did not work out, so that does not make it a perfect square trinomial. So just recognize that just because you see a square on the ends there does not make it a perfect square trinomial. That's really, really important. You can't just assume it. You do have to double check. So let's move on to some of these examples here, and let's take a look. So we're checking. We see, all right, we've got some perfect squares on each end. Oops. Almost put the answer in there. We've got some perfect squares on each end. Well, we know that the square root of x squared is x, and we know that the square root of 64 is 8. All right, well, let's just check this. 8 times x is 8x times 2. So 2 of those give us 16x. And then going right back up here. Yep, that is exactly what we need to see. So that means this is a perfect square trinomial. Now we know that's going to be like that, but is that a positive or a negative 8? Well, we go right here, and we take a look at what that sign is, and we know that this is a positive 8, and that is squared. There's our answer. Let's do number 13. Remember how I said you should pause and write down all those perfect squares so you have that to refer back to? Here is a really great time for having that on hand. If you don't know right offhand the square root of 169, you might not recognize that as a perfect square. Let's take a look and see what we've got. If you take the square root of r squared, take the square root of 169, and if you check that chart you made, we know that root of r squared is r, and we know that the square root of 169 is 13. All right, let's check that middle term. 13 times r is 13r. Minus 2 is 26r. So we know that does match the middle one, except we've got a negative right here. So 26r is not actually equal to negative 26r. We've got to make that a negative, which means we've got to make that 13 a negative, which means our answer is r minus 13 squared. Let's take a look at number 14. Now we can see that 36, first thing we need to do actually, is check for our GCF, and there's nothing in there. We might say, oh, 2's, nothing, so it's not able to take a 2 out, can't take 3. There's really no GCF, but we recognize our squares on either end. So what we want to do is take the square root of 36c squared and the square root of 49. That will give us 6c and 7. Now here's where it becomes really important to check that middle term. You can't just assume that you know that that's what that is. So 7 times 6c is 42c times 2 equals 84c. That is the middle term, so we know that that's going to be a perfect square trinomial. When we look here, that's a positive. I'm going to clean it up and put it all close together. There you go. Let's do this last one. Let's do 15 on this page, because that one looks a little scary. No, I'm sorry. Let's skip 15. I did mean the last one. But before we get to 19, we are going to do 18. So let's look at 18. Looks a little scary. We have some fractions, but luckily we all know what we're doing, right? The first thing we need to do is put this in standard form and make it equal to 0. So we've got n squared plus 2/3 n equals negative 1/9. Let's take that 1/9 over, bring it on over, taking off the dark side of course, and rewrite that. Plus 1/9. So, thinking back, when we squared fractions, we know that in order to multiply fractions, we multiply the top and then multiply the bottom numerator and the denominator. Well, we can see that 1, that's a perfect square, 9, that's a perfect square. So I believe that 1/9 will be a perfect square. And when you double check that, we get 1/3. Okay, so 1/3 times n gives us 1/3 n times 2, that gives us 2/3 n. We see that that's correct. We have a plus sign here. That makes our 1/3 positive. Let's square that. Let me just write this over here so it's easier to see. And there we go. Once you have those perfect squares memorized, it's not as scary when you're looking at fractions because you just really have to see the top and the bottom numbers are both perfect squares. All right, let's go to 19. Let's go to that last one, like I said. All right, we've got our k squared after the equal sign, so we know we've got to rewrite this in just a weird order. So, I'm going to add k squared over here, add k squared over here, rewrite that, GCF, I can't take anything out of any of those, but I see I can take the square root of k squared. I know that 9 is a perfect square. I know that 25 is a perfect square. So I can take the square root of 9 25ths. That will give me k. And 3 fifths times k is 3 fifths k, times 2 is 6 fifths k, but right here we have a negative, which means our 3 fifths must also be negative. And there we go. Again, I can't say enough, memorize those perfect squares, because once you have those memorized, you just take one look at that and you say, oh, 9 25ths, I can definitely take the square root of that. Also, the pattern of when you look at these trinomials, it'll save so much time because you're not going to have to FOIL everything out. Now, you could have FOILed it all out, but if you know this pattern, you save 2 steps out of the middle there, and you don't have to do the magic number. Let's do number 20 and take a look and see if we can figure out what that is. So, we've got the dimensions of a rectangular prism, which are x plus 1 feet by x plus 2 feet by 4 feet. And we are given the volume in another binomial, which is 24x minus 1 cubic feet. So, as Mr. Reyes told us, the first thing we're going to do is draw this prism, which, as I mentioned, I am the greatest artist you've ever seen, and that's completely to scale. I'm just kidding, that's terrible, and I realize that my angle is not perfect, and you guys love me anyway. I'm really glad I'm here. All right, so we have x plus 1 and x plus 2 are our width and our length, and we're just going to call them width, we're going to call them length, and we're going to say that this 4 feet is our height, because volume is width, oops, times length times height, and we know our volume is 24x minus 1. All right. So let's fill in all these letters that we have. X plus 1 times x plus 2 times 4 equals 24 x minus 1. That is a lot. That is a lot to take in. That's a lot of numbers, a lot of variables, a lot of binomials. But guess what? We have all the tools in our toolkit to figure this out. So the first thing we're going to do is we are going to multiply these first two terms, these first two binomials. And we're going to get x squared. And we'll take our inner, which is going to be 2x. So we can combine some like terms. X plus 2. Still have this 4 hanging out. Still not do anything with this side yet. Now we're going to distribute that 4, which will give us 4x squared plus 12x plus 8. And still not doing anything with this guy on this side until right now. So, wow, that made that look a lot easier. We've got a trinomial that equals a binomial, and luckily we know exactly what to do to set this to equal. We are going to subtract that 24, and we're going to add that 1. Go ahead and write that underneath. Keep them in order. We will then get 4x squared minus 12x plus 9 equals 0, and we are most of the way through this problem. Okay, so the first thing we're going to want to do is see if there is a GCF. And, oh great, I have 4 and I have a 12, which means those will, except they won't because I have a 9. But, because I know all of my perfect squares, I know that 4x squared is a perfect square, and 9 is a perfect square, which will give me 2x and a 3. Let's double check those terms. 3 times 2x is going to give me 6x. Times 2 will definitely give me 12x, but I see I have a negative here, which means there's got to be a negative there. And we have figured that out because that is a perfect square trinomial. So we are going to find the value of x. We've got 2x minus 3 equals 0. And that 3 of x. And x equals 3 halves. Is it a plus or minus 3 halves? No, because if we were to write this out, it would actually be 2x minus 3 times 2x minus 3. So don't make that mistake of saying, oh, I've got the same thing, so that must be a plus or minus. Make sure that you understand that that is not a plus or minus, that is only one sign because that binomial is multiplied by itself. So we're going to stop here. We're going to work on a few of these tomorrow in class, and I hope that you guys write down some questions for me. Let me know if I need to clarify anything for you, and I will see you tomorrow.